Hello, today I would like to demonstrate new client libraries for Go to interact with Choria. In the past, we had Puppet libraries. You were able to really quickly, 2 or 3 lines of code, interact with a fleet of M-Collective nodes or Choria nodes. You would be able to invoke remote actions, discover the fleet, display the results, interact with the data coming back, all this kind of stuff. Very, very compactly, 2 or 3 lines of code can achieve all of that. Though it came with a drawback, which is they were optimized for that use case and they were not very good for dealing with long running clients, things like you want to put into a daemon that manages a fleet of nodes. We have, of course, had Go libraries for over a year now. They're super efficient. If you do not do anything that touches the disk or take a long time on every node, they can round trip a 50,000 node fleet in 2 to 3 seconds. So they're very efficient. They create multiple connections to the network. They will use your available cores on your machine. They will process the results coming out in parallel. They're very, very efficient and very suitable to making long-running daemons that interacts with your fleet. Using these libraries, we've done a number of things, both in open source, where we have things like Choria Provisioner, but also I've done some closed source work, things like continuous delivery system that was continuously managing hundreds of thousands of nodes. That had the opposite. It was difficult to use, quite verbose, quite a lot of error checking, and so it was opposite end of the spectrum there. And what I'm trying to do today is show you how we will try to find a middle ground there between ease of use and high performance and stability. So a little bit of background on Choria again. Choria is a service that hosts agents on your nodes. Those agents expose APIs, and within those APIs are actions you can perform. So here is a description of a remote agent. It manages the lifecycle of Puppet. Within there, you have actions like disable, enable, cause Puppet to run, retrieve the status of Puppet, retrieve statistics about Puppet, and so forth. This JSON file describes the capabilities of the remote agent, and so it's equivalent to like a JSON schema or an Open API or a Swagger document or a WSDL file. And so we create a thing called, we're busy creating a generator that allows you to generate clients to interact with Choria based on these files. So Choria generate from this JSON file, put the output for me there. We have a library there. It's a normal Go library that can interact with all of the various things. And it supports, of course, Go mod. And we have to do one little thing here just to deal with a bug that's in one of my libraries. So what I'm going to demonstrate is how to enable and disable Puppet from Go. I will show you just a little bit about what this is about. So if we did sudo puppet agent disable testing, this will prevent Puppet from doing any runs. If I were to try to run at the moment, it's going to say, sorry, it's disabled because of testing. And I'm going to enable it again. Okay. Now, we want to do that, but across the network against a number of machines. So we're going to make a command that says disable and enable. We'll start first with disable. Standard stuff. Now we're going to interact with Puppet. And so we want to connect to our Puppet client that we created. It will do the usual auto import stuff. Lovely Go. Okay. Now this Puppet client that we have here, it has all of the actions that's supported. Get summary, get the status, cause runs, query individual resources on the machine, and there's a bunch of options and things like that. So for now, we're going to focus on disable. You can see disable performs disable action, description disable the Puppet agent. That description comes directly out of the DDL, so you can get some information about what this is going to do on your machines. It has a optional input, which is the message. And then you just have to get it done. Now, you need a context. Context is our kind of how Go handles things like Control-C being pressed. You pass these things into all your routines, and then should something trigger it, the context will communicate the fact that that trigger happened to the calling code. And so here I'm passing it into my Choria libraries, and that will tell the Choria libraries to disconnect from the net. So, ignore the result for the moment, and panic if there's an error. And that should be enough. Now, this code is enough to connect to the network, set up our security, use our security libraries. If you, for instance, had the PKCS 11 support that we announced last week configured, you would have to press your YubiKey to use this code. If you don't have, you need a certificate. My user here has already set up all of that stuff. So this code will do all of that. It will connect to the network, stand on all the protocols, all the security layers, discovery, all that kind of stuff. So go run main. It will go off, first compile the code, discover my fleet, and disable Puppet on all of the machines. Now let's just verify that it actually worked. If I was to do a Puppet run here, we will see testing from Golang. So it got disabled. The lack of feedback is a problem, so let's see how we would interact with these results. Each output, of course, the action produces outputs in the language of, in the terminology of Choria. It's an output, and it's going to be of type disable output. Now, in the output is, of course, the results. Was the thing disabled or not, but also was it successful, that there wasn't nodes responding. Maybe you didn't have permission to interact with the nodes. Maybe the machine didn't have the agent configured. Any number of things can go wrong. So we really need to handle both situations where the request passed, but also where it failed. And so when it passed, we will print the machine and what the status is. So result status, sender is who sent it, and status. So the enabled you'll see is bool and status is string. Within my DDL, I describe the types of data coming back from the remote nodes as boolean and string, and so when it generates the Go stubs, it will do the right thing. Unfortunately, the output type is optional, and so if you didn't specify it in your DDLs, or you intend to do it but you haven't yet, you will get an interface back, not a bool or a string. You will still get the data, but you will need to do the typecasting yourself. Where if you do mark up the DDLs of the output types, it will typecast for you. Okay, so we want to do print status there. If it fails, we will do almost the same thing, fail and y. We sent it, and what went wrong? Okay, what's it complaining about? Okay, that's it. Now, the enable and disable actions are designed so that if a node is already disabled and you try to disable it again, it will fail, because if I'm doing maintenance on a machine and I've disabled it, and you are trying to start maintenance on the same machine and disable it, I don't want you to start your maintenance possibly causing issues with my maintenance schedule. So that failure will communicate that you should investigate what's going on. Let's run it again. You'll remember we've previously disabled it, so if it works, we should get some error messages here. And you can see none of the machines were able to disable because they were already disabled. Let's quickly make a companion tool here for enabling. It's going to be very, very similar. So I'm going to copy and paste this over. So here we will call the enable action. It doesn't have any inputs, so nothing is offered. And here we will get the enable output. The rest should be the same. Go run enable main, discovers the fleet, enables Puppet across a lot. And likewise, if I were to run this twice, it would fail because it will not re-enable already enabled machines. So here we got success, it worked, and now I can disable them again. Discovers the fleet, calls out to the fleet, they load up Ruby, they load up Puppet, they ask Puppet to disable themselves, they respond, and I get the output. Okay, and that's it. What you see on the screen is enough to interact with the fleet, do all of security, connect to the network, do SRE-based discovery, find your brokers. It will do this against 50,000 nodes in seconds. Here, of course, it's a bit slow because I'm waiting on Puppet. Loading up Puppet libraries on its own just takes a second or two. And this is one machine with a bunch of VMs, so it's not the most optimal network. If I were to test this on a network where, let's say, I'm just doing a in-memory only process, just to send a reply ping back. So just to test the round trip overhead, I can manage 50,000 nodes in 2 to 3 seconds using just this code. It's that efficient. Now we can quickly have a look at something here. If I compile this, it's 12 megabytes, which is not exactly small. However, it has no dependencies. You don't need DDLs or any of that kind of stuff. If you give this to another person and they have the Choria security initialized in their user account, they can run it. We don't need to install anything. We don't need to transfer DDLs, nothing. You can just run that. It works. It does what you want to do. Now, this is, as I said, aimed at writing not necessarily these kind of CLIs. You'd be better off using the Ruby one for a CLI like this. But I wanted to show the level of interaction you get, the verbosity, and so forth. There's some other interesting things here. For instance, Puppet, well, Collective and Choria has always had various things to let you do things like canaries and things like batches. If you can do 50,000 nodes, you don't want to kick Puppet off on them all at the same time. You want to go, let's say, 20 at a time or 100 at a time. And so we could do in batches of 100 with a 60-second sleep between them. And we want to do run once, and we want to do force, and that will immediately, on 100 nodes, kick off Puppet, wait 60 seconds, do the next Puppet run on the next 100 nodes. Force is an argument to the run once action declared in the DDL. So all of these kind of batching and limitations and choosing of subcollectives and all those kind of options are exposed, as is, of course, discovery. So let's say fact filter, country equals empty. I only want to hit my machines in Malta, or for a specific customer, or for a specific cluster. All of those kind of things are available. And that's enough to use it, all nicely chainable. The style of API is inspired by Google Cloud APIs. This is how they work as well. This kind of nice chainable, and I really like it. I think it's quite obvious how it works. So that's it. I'm still working on the generator. I will hopefully ship it in the next couple of weeks, at least early version of it. If you would like to play with it, get in touch. I can give you a compiled version, or you can even compile it yourself. And I would love to hear your feedback. Thank you very much.